All right. Welcome, everybody, to our 4 o'clock session. This is Send Television Images Using Amateur Radio. How can images be sent using sounds with Randy Hall? Just go over the rules really quickly. So make sure you name yourself with just your first name. Keep your video off unless you're okay with being recorded, because this event is being recorded. Please stay muted unless you are asked otherwise. And use the chat box if you have any questions. You can chat them to our speaker. And with that, Randy, I'll turn it over to you.
All right. Hi, everybody. Glad to be here, and I hope you guys are. This one's a little. I know that normally, if we were doing this sort of event, it would be hopefully a little more hands-on. We can't be as hands-on here, but I will do my best to give you something to kind of some resources and something to look at. So, this is my central thesis of my talk is that SSTV is the original Instagram. So if you I will make some parts of my case in this presentation. I'll tell you a little more about everything and the history thereof. So. All right, let's dive in. So who is this guy? And you don't know me from anyone, so I was just by way of mention, this handsome fellow up here in the top right clearly has a lot less gray hair than I do, but he's not my younger brother. But anyhow, I am a teacher at a high school in Sonoma County. I actually teach video and digital media to high schoolers, and I really enjoy my job.
Randy, real quickly, you're not sharing your screen, so I just want to
I'm not sharing my screen.
No, you're not. So go ahead and pull that up.
Well, that's tragic. I have to start all over again? Oh, man. Burn. Hey, thanks for letting me know before it got really awkward.
Yeah, absolutely.
How's that?
That's better. Yep.
All right. Thanks for reminding me. Okay. Let's start over, shall we? Okay. Hi. Anyhow, my thesis is that we're going to talk about the original Instagram, which I call Slow Scan TV. All right, so there you go. Now you can see who's this dapper fellow on the right-hand side. I am a teacher at a high school in Sonoma County. I teach digital media and filmmaking and to high school students, and I love doing that. It's really been a lot of fun. I've been doing it for 4 years now. This year has been challenging, I won't lie. I'm also an amateur radio operator, or a ham, as they would say. And I've been doing that since 2017. So I haven't been using amateur radio or playing with radios in this sense for very long, but it's something that is a real big interest of mine, and I really enjoy it too. I started off, with the first level of licensing, and I've now licensed what they call an amateur extra, which is the highest level of licensing you can have in amateur radio. And my call sign is AA6RH, and I got to choose that. So it was not just assigned to me. I actually said, hey, I'd like that call sign, and they said, okay. So yeah. And yes, being that I teach digital media and video, I really enjoy visual communication. That's kind of my jam. So this kind of technology really speaks to me personally. So what you're hearing right now is amateur. That's Slow Scan TV coming in over the computer. You guys do hear it, right? I think so. The idea behind this is that
Randy, we can't hear that.
You're not hearing it. Okay, cool. How about now? Is that better?
Yes.
Okay, so what you're seeing is Slow Scan TV. That's the tones. These are it's actually the sounds that Slow Scan television makes. And if you listen closely, you hear a rhythm to it, right? There's these warbling tones, and then there's kind of a click. So yeah, there's a rhythm to it. It is actually a method of using the audio to transmit an image. And it uses a normal audio channel in radio. It doesn't use, it's not like television broadcast, like analog broadcast TV like you'd get on a TV set, which is way more radio frequency spectrum gets used in that. So this is like really tiny, like a regular radio kind of device can transmit this. And the technology itself dates back to over 60 years, so it's older than I am. Thank goodness for that. So there's a lot to it, and that'll be the end of the sound part. Okay. So the interesting thing about it is that technology has been around for quite a while. So when we talk that it's been around a while, who used it back then? Well, people like myself back then would have used this technology, but they would have used it over these devices that you see on the screen, which are really it's like big old cameras that were analog television screens that were all kind of put together the way that they are, and would basically cost a mint in then and now. I think that we did the adjustment for inflation, and that this top radio set here, which is a robot, was the brand name, would be $5,000 in today's dollars for this setup. It was pretty impressive. The other people who used it back and then were astronauts. So actually, NASA used this kind of technology, slow scan television, to transmit images back from the surface of the moon over narrowband radio channels. So because they couldn't put a really gigantic transmitter on the lunar lander or even on the orbiter, they actually had to use these much narrower radio channels to be able to transmit images back. Now, they didn't use the same exact technology that we are using, that I'm talking about today, but it's similar. This was able to send 10 frames a second back to Earth from the moon, and then was basically reformatted to go out over televisions back then in the 1960s. So now you fast forward to today and you think, okay, well, who uses this now? Well, I mean, kind of the same people, really. So amateur radio operators like myself who are interested in this sort of technology, and it's just a different way of communicating with people. They use radios. Sometimes they might use cameras. They often use just images that they've gotten from other sources or that they've created. And then use that as the source material for the media that gets sent across. And then also astronauts, believe it or not. So, and there's a little star there because astronauts who are also amateur radio licensed do this as well. So this is a picture of Doug Wheelock, whose amateur call sign is KF5BOC, and he has spent years, he's literally spent, not years, I wouldn't say years, but he's spent a lot of time on the International Space Station and on space shuttles in his career, and he really was, one of the things he enjoyed was doing amateur radio as well. There's a third group of people that have used this, believe it or not, and it's really weird. Video game developers have actually used this as kind of an Easter egg content in the game. So Valve software, if you've ever heard of the Portal or Portal 2 games that work on computers, there were parts of that game where you had you had this group of these different images, these different audio sounds that you'd hear, and if you knew what that was like, hey, that sounds like slow scan TV, you could hold up a device that would record the sound, and then you could decode it into an image, and these were the images that you could see. You can see that they're definitely all kind of warbly and garbled because they were received just like any other slow scan TV image that amateurs deal with today. So why do I think that this is the original Instagram? Well, to do that, I got to kind of compare the two. So let's take a moment to kind of really dive into that. So let's start with slow scan TV. Slow scan TV is you use it to communicate visually. So you're using it to communicate with images. Primarily, that's what you're doing. It's publicly viewable because they're going out over the air. They're going out over radio waves. Radio waves, nobody can keep you from receiving those. And based on rules, we're not allowed to obfuscate it or encrypt things so that anyone other than the intended receiver can't receive it. So realistically, we're sending things out and anybody can receive them. And we can obviously add text to images. I'll demonstrate a little bit of that in just a moment. And you can also, and so actually the key thing that's required is you need a radio, you need a computer, and in our case, you need a license. So you need to actually be qualified and approved to use this device. Now let's compare that to Instagram. Now, Instagram communicates visually, right? It's with images. And for the most part, it's publicly visible. Now, I would not recommend any teenagers or below ever try to set up a public Instagram account. That's definitely not what we're advocating here. But, for the most part, you can go follow, celebrities and other people who make their profiles open to everyone. And then you obviously can add text to images. That's also part of the platform itself. And you need a smartphone with an internet connection. But what is a smartphone? It's a computer with a radio in it. So really, they're practically the same thing, right? So, so yes, it's not. I'm not being totally serious here. It is obviously not the same thing, but it's remarkably similar, and it has the same level of enjoyment, and that's part of the reason why we do it. We play with this. Okay, so how does it work? Well, you've already heard what it sounds like, so I'm not going to play that for you again. But what you would do is you would create an image. All right, you'd start with an image, and you might capture that image on a selfie or with your own camera on your own device, or it could be one that you've produced some other way, or it could be an image that you found on the internet. It could be, the sky is very blue here. You definitely, there's no boundaries on that. You could also use a website like Canva, or it's also an app on iOS and Android, that you can go using graphic design tools. You can create an image. And finally, there's also, you could do memes, right? I mean, those are pretty well used. And Image Flip is a site that you can go to and use the meme generator, and you can drop text on top of very, very very popular images that you've seen countless times on social media. Then you convert that image. So you take that image, you've created it, and now you convert it into this audio. And then you're going to send it over the air using radio. So you're going to convert this image to audio noises, and then that's going to be sent out over radio. And then it arrives on the other side. So there's going to be another radio on the other side. There's going to be some software. This image right here is of the software package I'm going to be showing you today, which is called SSTV. I know it's a weird, it's letter salad, but it's actually, it's got the initials of the person who wrote it, and SSTV for Slow Scan TV. So this is the flow. This is how you would take an image, turn it into tones, send it over radio, and then it gets received and turned back into an image. So it's not particularly challenging from that perspective conceptually. So let's actually have a look at what it looks like, okay? So now to do that, I'm going to move this over here, and I'm going to turn over to this, okay? So now what you're seeing is this is part of my desktop. I've got it on. This is the best part about being a teacher, is I've got my own little setup here. And I do this 5 days a week, so I've been practicing it for a while. I have a camera here, a separate camera that's showing this setup on the desktop. This is actually my little one side. I'm going to turn this radio on. And this is a Kenwood amateur radio that's VHF, so it broadcasts over this frequency, 144 decimal 500 megahertz. So that's VHF, and it's run through this cable right here into this Android phone, running an app called Robot 36. So see, there's the app is called Robot 36. And all you see it doing is it's just kind of scanning. There's some little graphical indications as to what kind of sound it's receiving at the moment. And then there's a sweep that's basically kind of crawling down. You can kind of barely making it out that it's kind of doing it. Because there's nothing visual, it's just noise. So that's all you're seeing is just color noise on the screen. On the right-hand side, don't mind me bumping everything. On the right-hand side, you have this program called SSTV that's on this computer, the computer I'm using to talk to you today, and is running through a separate radio. I don't have that radio on camera because it's kind of off to the side here, and it's much bigger actually. It's not a tiny radio like this. It's actually quite large, and is running to an outside antenna. The reason I originally was going to show you with the antenna on this radio is kind of a proof of that it's not going to that I'm not trying to fake you out. So, but the problem is that every time this transmits, this camera right here turns off. So I thought, well, I'll just run a line out too. So the antenna is just a couple feet off to the left here. So yeah, this is the setup. Okay, so it's as simple as something like this. Now this radio here is about I think it's $150 radio. It's not like super expensive. I know that scale is everything, and one thing you'll understand about hams is that the gear is part of the shop talk. And this is just my daily smartphone that I have. So it's like there's not a whole lot of investment here in terms of money. And so that's and we'll talk about what it takes to get started in this if you're interested. So on the right-hand side, we've got this. And what I'm going to do is I'm actually going to transmit this image from this computer to the phone, and you're going to see it show up on the phone. And in order to do things according to the way that I should be doing them in amateur radio, I need to kind of check that the frequency's clear. And I'm just going to listen. Okay, and the static you're hearing is that static that you're seeing on screen. I'm actually also going to transmit my call sign, but I'm not going to use voice. I'm going to use Morse code, and that, we call it CW. So if I click this button, you'll see that I transmit my call sign out. If you guys want to hear it, I will do it one more time. Actually, I'm not sure that I can I can loop it in using this. So I'll try to make it quietish so that it's not too loud. Let me try one more time. Okay, it's not terribly loud, but that's the sound that my call sign makes when you translate it into Morse code. Now, what I'm going to do is I'm actually going to transmit this image. So I'm going to press this TX button, and then what's going to happen is you're going to notice this graph here is going to change. There'll be a line that sweeps down the screen, and then the image is going to show up over here. So here we go. You'll notice that there's a little bit of a receive indicator on the radio. There's the image showing up here. I'll play a little bit of the... Those are the actual tones that are going on. Okay. And this actually is looking like it might be a clean image. It's funny that every time you send and receive, nope, there's some glitch. Okay, cool. Because I actually was kind of looking forward to it being the key thing that you get from that is look at there's banding, there's smearing. It's not as sharp as the original image. So literally, if I bring this up to show you, that image is not anything close to the quality of the original. And that's actually on purpose. That's actually part of what makes it interesting, is that every time you receive an image, it's a little bit different. It's going to be there's going to be some kind of, analog quality to it. And, that's kind of what makes it a little bit more visually interesting to me. Okay, so now we're going to do the reverse. We're going to actually send something back. So I'm going to flip over to this app. This one actually sends the images. The other one receives. So what I've got for you here is I actually created a little text thing here, but I pulled up an image that I created in Canva. This one is actually about Pi Day, because tomorrow's Pi Day, so happy Pi Day, everybody. And I'm going to, and you'll notice that I've actually put my call sign in here. So it has my call sign in the image itself. So if anyone receives the image, they know that I sent it. And also because today we're doing this North Bay Science Discovery Day, I'm putting that in the image as well. And then I'm going to send this back over. So let me set this up to receive. And then you'll see the image come back over here, and it might it's going to definitely probably have similar glitching sort of analog qualities to it. So I'm just going to press the play button, and then this radio is going to start transmitting. And so as it's coming in, you'll notice it doesn't. Again, it's not going to look as beautiful or as pristine as the original image, and that's kind of on purpose. It's not meant to be a digital copy of the original. And yes, there's going to be glitches again, because even radios that are this close together, it's actually not trivial to get a completely clean image from one end to the other. Now, this is using the same sort of technology that, like I said, was used on on the moon, the lunar missions back in the 1960s. So this is it's pretty interesting and kind of fun to play with. So that is the short answer of this demo. Actually, what I'll do is I'm going to open the chat here real quick to take a look and see. Okay, so there's some questions. So what is bandwidth? Okay, so bandwidth is, if you talk about radio frequencies, okay, so these are, just how much radio frequency that you get is, well, the best way to think about this is that certain applications, like in radio, will use a certain space of frequencies from a start frequency to an end frequency, and that gap there, that delta, is the bandwidth. Okay, because you're actually talking about the width of the radio frequency that you're using. That when you talk about different radio frequency ranges, they're described as bands. So if you just put the two together, bandwidth is the radio frequency itself. Like this one is 144 megahertz is the band. And the bandwidth in this case is really a regular radio channel in amateur radio is what they would say is 25 kilohertz, which is cycles per second. So frequency is measured in hertz. So when I talk about 144 megahertz, that's million hertz, and the 25 kilohertz is 25,000. So that would be, the last two zeros on this indicator here would be the thousands. Okay, so 500,000 is so it's 1,444. Or 144,500,000 hertz, if you wanted to it that way. It's harder to describe that way, and it doesn't kind of come off. It doesn't roll off the tongue, and so we like to shorten it with those the mega, the kilo, and so on. So yeah, what's a frame? So a frame in I'm not sure in what context you're asking that one, but it could be the actual visual frame here is what I think you might be. Go ahead.
Or how do you? No, stop doing that. Just go to the next one. How does each pixel value translate to an audio value or something? Well, no,
Okay.
I want the if part. Come on.
But sounds like that's lively. I would say that there's actually multiple different techniques that go into that. I wasn't going to go deeply into the weeds on that one because I didn't have that much time. I can point you in the direction of some resources on that. There is actually Wikipedia's entry on SlowScan TV does touch on some of those. There are familiar and relatively consistent things that all SlowScan TV encodings use, but you'll notice that there are a bunch here. There's on this part of the screen. There's all of these. We've been using this one called Robot 36, but there's other ones, Robot 32. We'll talk more about PD 120, and there's a bunch of different ones that you will find as available. And this was confusing when I first started playing with this. I was like, well, how do you choose which one? And a lot of it is, depending on what you're trying to do and how strong a signal are you? Because some of these are better suited for very weak, long distance radio hops. So yeah, actually, yes, I agree with this. I wonder whether this would make an even more impression artwork than impressionistic, or make something that's impressionistic even more so. Absolutely, you're taking something and kind of mangling it, and when you reassemble it, it's not going to be purely the original. So every one of these is a unique piece of art itself, and I do actually refer to it that way. What is the sync? The sync is actually, and actually in this one, this is actually tells you this actually has to do with the tones that are coming across and how they are received. And what you're looking for here is you like that white band on the left-hand side to be vertical. So this little glitch here in the middle is where the sync was way, way off. But the rest of it was lined up, and that actually has to do with I've calibrated my sound card to receive this way. So there's a lot of there's some tweaks that go involved in that. Is the image size fixed? Yes, actually the image sizes are predetermined. Actually, if you look here, you can see that this one is 320 by 240. And many of them are about that size. Some of these, like the PD 120, will do 640 by 480. So that's like 4 times the same resolution. And frames per second. Okay, got that. So if RGB can go from 0 to 255, how does each pixel value map to an audio value? Got it. Yeah, so it sometimes the values are encoded by frequency. So you'll see that there are actually, there's frequency ranges here that are for different, the 1200 here is the sync frequency, and then from 1500 to 2300 hertz, these are again cycles per second. These are audible tones though that you can hear, would be from I don't remember which segment of these is red, green, and blue for this particular encoding, but it does vary between one encoding and another. I like these questions. You guys are doing great. Thank you for asking these. Okay, so I'm going to switch back to the talk. So I'm going to bring this back over, and you're going to see it for a sec, and then I'm going to flip it over to here. There we go. Okay. Phew, boy, that was fun. All right. So you were reminded that I actually did talk about that astronauts are using SlowScan TV, and that there is an amateur radio installation up in the International Space Station. And specifically, the one that's in the service module of the ISS periodically schedules these SlowScan TV transmissions. And they're repeated over several days. Sometimes the event goes a couple of days. Sometimes it goes for a couple of weeks. It's challenging, but relatively easy to receive them. So it's actually kind of, it can be a fun way to spend some time. Why do I say that? Well, it's easy because, when the ISS is flying overhead, there's really nothing in the way. It's clear line of sight. So radio will travel very, very well if there's no obstructions. There's nothing between you and the transmitter. That's the best case scenario for most radio. Cheap-ish amateur radios can receive the audio. Like, for instance, this little Kenwood thing that I have here. There are cheaper radios that can receive this stuff. It doesn't take a lot. A cable can plug into your phone to decode it, like the one that I used here for the demo. But it's also challenging because not every pass that the ISS makes is going to be directly overhead. The ISS, and we'll talk more about the ISS and how it and its behavior in just a second, because passes happen at different times each day. Sometimes those passes are not particularly convenient, and things can go awry on the space station or even on the ground, and those transmissions don't happen. So there are things that can prevent it from going off well. For instance, this was an event that the International Space Station did in the end of December, where they did 12 images, and it started 2 weeks before. It started on the I want to say it started on the 14th and went to the 31st. So it was 2 weeks of this station being on the air transmitting these images. It took me literally 2 weeks to capture all 12, because, as I said, sometimes the space station is passing overhead at 2 a.m. Sometimes sometimes when it is passing overhead and I'm receiving, it's transmitting an image I've already received. It's like you get what you get. It's like fishing. And that's the best way I've described it. It's like you don't do this to catch fish. You do it because it's kind of enjoyable to just tinker with this stuff. And when you do actually get something on the line, if you want to use the fishing analogy, and you start to see this image appear, you really get excited, because it's like, oh, cool, I wonder which one it is. And then you see which one it is, and either it's one you've already gotten and you're like, oh, it's one I've already gotten, or it's one you haven't and you're like, oh, sweet, cool. It's like baseball cards or any other collecting that you might do. It's really kind of an interesting approach. So why would you do this, right? The way I describe it is, I think that receiving radio from ISS is actually fun. It's relatively easy. I was shocked when I took a radio with just a regular, like a radio like this, with just a little antenna on the end of it. I could receive radio from the ISS using this. Okay, it wasn't perfectly clear audio, but I could hear it, and I could hear that it was slow scan TV tones. There is also other radio transmitters in the ISS for ground-based, for student contacts and stuff like that. I'll be doing a talk about that at 5 o'clock. So and to the comment before is, like, received images are kind of a unique work of art. With these images here, it's like nobody else got images that look exactly like these. Okay. These are unique to me. These were my images. These are ones that I got. And it makes it feel personal. And you really, these are the best ones. I obviously got multiples of each, and I picked the best looking ones. And some of these have, some of these have noise in them. Some of them, this was the only image I did not get the entire image of. Is I got like 3/4 of it, and then it just kind of faded into this green noise. So number 11 out of the series of 12 was the only one I didn't get all of them. I didn't get the entire image, and boy, I'll tell you, that rankled me. So, received images are definitely a work of art. Each time the ISS is passing overhead, it kind of becomes an event for you, because you're like, oh, it's time to go outside and get ready to do this, because it's happening, and you get really you can be different levels of excited depending on whether it's a glancing blow of the ISS on the horizon, or maybe it's a directly overhead pass that's going to be like super long, and so maybe you'll get 2 images, maybe you'll get 3. You know, it's depends on the timing, and it really does become a thing. And as I showed you, it's easy to kind of get started on this. It's not particularly challenging. And it can get as sophisticated as you want. Okay, so we're going to, and we'll talk about that in a second. So the question about how do I know when it's going to pass? You can do and send. You can also send and receive SSTV with other people on the ground. You're not just getting it from the ISS. You can actually transmit and receive this as well, just like my demo. So let's talk about this. So again, this is starting out. You can see that this is the same desk, the same. It's not the same radio. This is a different radio. Like I said, when you're an amateur, you start to collect these things, and they show up. They start to just kind of. Ooh, that's another good question. I'll get to that in a second as well. Then later on, as I was receiving these images from the ISS, you see where I have a different radio in place. This was just for receiving. This is not the radio I use today for the demo. This is just a different radio that I have. Like I said, they just start showing up. And then this is actually the radio I am using for the big radio that I used. This is a company called Yaesu, and the model. It's a very, very complete radio. You can use it for all kinds of different stuff in amateur radio land. So here are some places to check out for some SSTV info. Okay, and let me see if I can paste these or put these in the chat for you guys. I'm going to have to type them because I didn't have them handy. Eris, SSTV, blogspot.com. And actually, you can get to this next one from that first SSTV. There. Okay, so there's the second link. And both of these are places that you can go find out when the ISS is going to be doing these slow scan TV events. Right now, they're kind of offline for different reasons, but so there hasn't been really any big one yet this year. The last big one was at the end of December. And on the right-hand side, you see that this is actually the gallery where you can see what amateurs have received from the ISS. What you see on the screen are images from this end of January event that they did, but the ISS was really only transmitting over Europe. So if over North America, you really never got anything from this. Okay. You also can listen in. So this is this is one thing for you to consider, is that you can take an inexpensive USB. It's called an RTL SDR, and I do have one around here somewhere, probably not within reach, but it's this little USB. Device that you can plug in, and it has a radio receiver in it, and you can use free software for Windows or Mac or Linux to be able to listen to radio signals, including stuff from outer space. Free software is available to decode SSTV as well. As I said, I showed you the SSTV in the demo here. That's free software, free to use, and the fun thing about RTL SDRs and things like that is that it's also fun for other stuff as well. Okay, but that's a totally different talk for a different day. But realistically, this technology is not out of reach for anybody, and it can be a really kind of interesting way to get yourself involved and play with kind of a different approach to electromagnetic energy. So if you really, it's like literally thinking, gosh, I'm listening to just things that are invisible, and it still can be marvelous. I know that there's a lot of talk about digital technology has kind of ruined children and generation. But what I know from my students is they kind of crave the analog. They're craving this kind of this strong push back to like, hey, vinyl records are cool and interesting, and those are created purely from an analog kind of medium. And so radio is that same sort of thing where you actually are if you're able to translate something from an image domain to an audio domain and then back to an image, and in that process you're able to transport it hundreds, thousands of miles, that's actually pretty interesting. And it doesn't use the internet. So, all right. So I think that is it kind of wraps up my talk in terms of the content that I've got. These are some great questions. The question about website or links. Have people used the audio in compositions? I don't know that I've ever heard slow scan TV signals be used in that way, but I wouldn't. You probably could. I mean, it could be. I bet you that you could sample it and run it through some audio synthesis or through some filtering envelopes and other things like that. To if you're in a digital musician or even a musician with analog synthesizers, you can sample this stuff and play it through. And it would create, you could create a beat from it for sure. Yeah, I think it would be, but I've not heard of it being used in a musical sense. I think that's what you're asking about in terms of composition here. Yeah, I think that it would be possible for sure. I don't know of any myself though. What happens when you feed music into SSTV? That's actually a good question. You get garbage. What's funny is that you actually, when I played the tones, if you recall, when I did the demo, I had the screen up here and I was playing my call sign in Morse code, and it's just it's like those tones. That actually registered as green on the screen while it was transmitting those tones. So I think that if you ran music through an SSTV decoder, you probably wouldn't get something that would be well, I don't know. Actually, that's a really good question, and that's actually worth playing with. I'm probably going to do that because I'm like, well, I wonder what it does though. I bet I could do that. And I mean, I've got all of the stuff here. I could probably do it. If you gave me a couple minutes, I could probably set something up, but yeah. Any other questions? I love these. These are really awesome. You guys are coming in out of left field with all sorts of stuff. Let me find, I actually will, let me see if I can get the, I'm going to pull this over here. Let me see if I can find the link to this presentation. I'm happy to hand it over to you guys, and you guys can look at it in more detail if you'd like. So it's a Google Slides presentation, so it's a pretty easy thing to take a look at. And I will, I'm going to get you the link. The link, unfortunately, is going to be kind of long, so just be ready. But you might be able to click it in once I get it into the chat. Okay, and I'm going to do this. I thought I had set this up to be free to anyone with the link, and I'm going to copy it now and paste it here. And go ahead and see if you guys can open this presentation and take a look if you'd like to look it over some more and pick it apart, have fun with it. I didn't do any notes with this, so I don't have a lot of extra information. If you are interested in more detail about any of those sites, what I will be talking more about contacting the amateur, the ISS in my next talk, which is in 15 minutes. And I go into more detail about how you might find when the the ISS is passing overhead. The site that I generally go to as my first order of business is Heavens Above, which is actually it's a free website to use, and I think I actually have my my observing location is set to where I'm at. Yep, okay, that's close enough anyway. So I will update that. And if I go over here to ISS and then click on all passes, you can see that this will show you visible and unlit. And you can see that there are, every day you're going to see that the ISS passes by. Like today is kind of fun because it passes by very early in the morning and then late at night. So it's got 6 passes today, which is actually kind of rare. You don't see 6 passes very often. And then the tomorrow for Pi Day, it's gonna pass over my location 5 times. So yeah, the fun fact is that the ISS passes over any spot on the Earth. It passes near any spot on the Earth about 5 times a day. It orbits the Earth 16 times a day. But any spot on Earth, it actually is going to be within view about 5 times, or 16 times an hour, I should say, or no, not 16 times an hour. That's not right either. It's like literally from one pass to another, it's about 90 minutes. So yeah, that sounds about right. 16 times a day. So yes, I'll put this link in the chat as well. That's heavensabove.com, but I will put that part. And what you can do is you can actually, when you click that link, what you'll get is you will get the idea of you do need to configure it first by changing your observing location. And if you do that, because if you start with it by default, here's what it looks like, is it puts you in the middle of the Atlantic Ocean. Of course it doesn't now because it's saved my location, but where it would normally send you is 0000, which is right about here on the map. So it's on the equator at the it's a little bit off, but not by much. So it would be basically 0 would be the latitude and longitude. So you need to update the latitude and longitude for where you are. And obviously for most of you, you're going to be Northern California. So you'd be over in this area and you'd scroll in here. And maybe you're something in Santa Rosa, Petaluma, or Marin County, Napa, anywhere like that. You can obviously click and dive into that as well. Any other questions? Because, yeah, these are really good. Okay. Thank you guys for being here for this talk, and I hope you got something out of it, and have yourselves a great